Ladies and gentlemen, let's graph this function f of x equals x squared using an input-output table. We've already done this before. I hope we could all do this again. Let's all make an xy table, which is an input-output table, and let's plug in some inputs like -3, -2, -1, 0, 1, 2, 3, even 4, why not? And if I were to plug in 0 into the x, 0 squared is 0. If I were to plug in the 1 into the x, 1 squared is 1. If I were to plug in 2 into the x, 2 squared is 4. Is everybody with me? If I were to plug in 3 into the x, 3 squared is 9. And of course, if we plug in -1 into the x, it's also going to be +1. If I plug in -2, it's also going to be +4. Plug in -3, it's also going to be +9. If I plugged in 4 into the x, 4 squared is 16, but that's obviously off the graph, so I'm not going to be using that coordinate. Let's graph 0, 0. Let's graph 1, 1. Let's graph 1, 2, 2, 3, 4. Let's graph 3 and 9. And let's go into the negative section, the -1, 1, the -2, 4, and the last one, the -3, +9. And as you can see, I'm graphing this as quickly as I can. And it is taking me a long time. But at the very least, I hope you guys understand this. Why? Because this is the easiest type of quadratic function. What's a quadratic? It's a variable x with an exponent of 2. And this is what we call a parent function. So everybody please write down parent function. Okay, now what's a parent function? Well, a parent means that you've had babies, right? So right here, a parent function, this is the parabola, and it's going to have babies. I'm just kidding, it's not going to have babies. But the other parabolas are going to look like this one, right? Just kind of like children look like their parents. The other parabolas that we graph, any x squared function, whether it has a number in the front or a number subtracted at the end, or even a negative in the front, it's going to be similar to this U-shaped curve, but it's going to undergo some type of change. And in mathematics, we're going to use the word transformation. So any parabola that we graph is going to look like this parent function. There's just going to be some type of transformation, right? Maybe instead of opening up, maybe it opens down, which we'll later call a reflection on the x-axis. Or maybe instead of having the vertex, the lowest point at 0, 0, maybe it gets shifted 5 units down and the parabola is down here. Or maybe it gets shifted this way and the parabola is over here on the side. So all the parabolas in this section are going to look like this, but it's just going to undergo some type of transformation. And in order to understand the transformations, I would like to go back to our functions, our absolute value functions. Now, this was the easiest type of absolute value function. This came from our notes. So if you have these notes, let's go look at this first example. This is the easiest type of absolute value function. And this absolute value function is also called a parent function. So I want you to go back to these notes and label this first one parent function. Now what do I mean by that? All of the other absolute value functions, they're all going to look like this, but they're going to undergo some type of transformation, some type of change, right? Maybe the V gets wider, or maybe the V gets narrower, or maybe the V gets reflected on the x-axis, which would mean it opens down instead of up. So there's some type of change that's going to go on, but if you ever graph any function that has y equals with the absolute value with x in there, it's going to look like a V, but it's going to undergo some type of change, some type of transformation. Anyway, we're going to be jumping back and forth, all right? Jumping back and forth. So let's go back to the notes right here. So what do you guys think of this parent graph? Was it easy to graph? Yes? Do you want it to be easier? Heck yeah. We're going to make it a lot easier. Check it out. Obviously, if I asked you to graph this one right here, y equals parentheses x minus 2 squared plus 4, it would be more challenging to do an input-output table. Like imagine that, I'll plug in 0, 0, take away 2, oh, that's -2. And then -2 squared, -2 in parentheses squared, that's 4. And then 4 plus 4, that's 8. That's a lot of math that you're doing, right? I want to show you guys a super easy, super awesome way. All we have to do is memorize vertex form. So ladies and gentlemen, we need to memorize this. And some of us are thinking, wait a minute, I already know that. I've already seen that before. Yes, you should have seen it in Algebra 1. But not only that, we also saw it right here on the absolute value functions. It's the same setup. Y equals, A's out in the front, X minus H. But right here we have absolute values, but it's the same thing as the parabolas that have parentheses here. The H is inside with the X. It's always being subtracted from X. You always think opposite on H, and you take K for what it is. Okay? So it's the same exact setup. So let me ask you this. When we go back to these notes, here's our parent function, right? What happens if I compare this parent function with this new one that had a K of -2? What happened to the actual graph? It got moved. It got moved where? 2 units down, right? So we're going to say that it shifted 2 units down. The K value will end up making your original parent graph shift either up or down. Okay. Now how about right here? Is this a K value? No. That's a H value, which you have to think opposite. And what could he tell me about the original parent graph compared to this new one? It got shifted where? 2 units to the right. And that comes from the H. So the H is going to cause a left or right shift, but you have to think opposite on H. So the H and the K will make the parent graph either shift left, right, or maybe up or down, or maybe both if you have both an H and a K. How about this though? What could he tell me about this V or this graph? Is it wider or is it exactly the same as this one? How about this one? It's exactly the same, right? Why is that? It's because the A values are all 1. Okay, the A value, how about this? Let's go to the other worksheet. You guys remember that other worksheet? Same section, but it was more practice. Everybody look at numbers 1 through 4. And if you didn't have it complete, just look at it right here. Look, all have the A value of 1. The A value of 1, the A value of 1. They all have the same width. None of them are wider or narrower than the rest. See, the A value, not only does it tell you if it opens up or down, but it also tells you if it's wider or narrower. Are you with me? Okay, like look at number 5, 6, and 7, and 8. The A value here is what? 1. That's a regular V. What happens if the A value gets closer to 0? It became a 1/2. What happened to it? It got wider. And then it got closer to 0, 1/3. 1/3 is even less than 1/2. What happened to it? It even got wider. 1/4 is even wider. Does that make sense? Now, what would happen if I took my parent graph and changed the A value of 1, which is a regular V, and I changed it to a 2? What happens? It got narrower. And what if I changed it to a 3? It got narrower. What if I changed it to a 4? It got narrower. Change to a 7, it's super narrow, right? So I want you to start understanding the way the A value affects your graph. First of all, the A will tell you if it opens up or down. If it's positive, it's going to open up. If it's negative, it's going to open down. Everybody's cool with that, right? Secondly, the A value tells you if it gets wider or narrower. And later on, we'll talk about something being wider. We're going to refer to that as a vertical compression. So like this one's wider, that we'd refer to that as a vertical compression. It's like if you got the regular V and crushed it, it got wider. And when you talk about a vertical stretch, that's like saying that it gets narrower. It's like taking the parent graph and stretching it out. But we'll get to that later. Right now, I just want you to understand, if the A value is positive, it opens up. If the A value is negative, it opens down. And if it's closer to 0, it's going to get wider. And if it's further away from 0, it's going to get narrower. Okay, so let's go back to our notes, because a parabola works exactly the same as what we just did right there. The A, the H, and the K, it all tells you the same thing. So what did the A tell us? It tells us 2 things. If it opens up or down, depending on if it's positive or negative. And it also tells us if it's wider or narrower, depending on if the A value is closer to 0 or further away from 0. So the A value tells us a lot. It tells us if it opens up or down, and it also tells us if it's wider than usual or narrower than usual, depending on your A value being closer to 0, which would be wider, or further away from 0, which would be narrower. Number 2, the h and k value. What did the h and k value tell us on the absolute value function? It told us the highest or the lowest point of your absolute value function. Now right here, it still tells you the highest or lowest point. So the hk is the highest or lowest point of your parabola, but it's called the vertex. Parabola. Oh, I misspelled parabola. Sorry about that. Parabola. Let's just scratch that out. Parabola. So it is the highest or lowest point of your parabola. I mean, obviously, if it opens up, it'll be your lowest point. If it opens down, it'll be your highest point. But that highest or lowest point is called the vertex. And we're also going to refer to the vertex in the future as the maximum value or the minimum value. All right, now the h and the k. The h obviously is the x on your vertex, and the k is the y on your vertex. But in addition to that, when we get to transformations, the h will tell you how many units you shift it to the left or to the right when you're looking at the original parent graph compared to your new graph. So let's write down h will tell you your shift left or right. So the h is definitely your shift left or right, but think opposite of what you see, right? You always have to think opposite of what you see on h. And the k is going to be your shift where? Up or down. Up or down. There we go. So if we truly understand that the a value tells you if it opens up or down, tells you if it's wider or narrower, if we truly understand that the hk is the highest or lowest point, which is called the vertex, then it'll be really easy to graph parabolas, right? Especially if we memorize this pattern. Okay, this is like your first homework assignment right here. Memorize the pattern 112439. 112439, memorize it, 112439. Change your cell phone passcode to 112439 to help you out, right? Now, where does this pattern come from? It comes from the parent graph that we just did up here. The coordinates. Everybody box this in, bubble it in, highlight it, I don't know. Make sure that you understand that that's where it came from, the pattern 112439. Now, why am I using this pattern? See, the deal is this. We know that if the a value, what's the a value right here on the parent graph? 1. Any quadratic function, any parabola that has the a value of 1, it's going to produce exactly this U-shaped curve. It's not going to be wider. It's not going to be narrower. If your a value is 1, because the a value determines if it's wider or narrower, right? If the a value is 1, it's going to be this exact width. It's not going to be wider. It's not going to be narrower. So we're going to use that to our advantage. We're going to be able to select that a value of 1 and use the pattern of 112439. Let me jump right into it. Look, here's an example of us graphing this parabola. Now, let me tell you right now, the very first thing you should identify when graphing a parabola is your vertex. Everybody put a little V right there. And what is the vertex? It's your h and your k. Think opposite on h. What is h? H will always be, ladies and gentlemen, it'll always be the value that's being subtracted from x inside parentheses or maybe inside absolute values. So let me ask you this. Do we even have any parentheses right here? No, we don't. So what's the h value? 0, right? If you wanted to, you could imagine some parentheses right there, and there is nothing being added or subtracted at the end of the x. So the h value truly is 0. So let's all put that as 0 for h. And what's the k value? It's the number that's being added or subtracted at the very end outside of the parentheses. -4. You take k for what it is, right? Think opposite on h, take k for what it is. So let's graph that vertex 0, -4. Let's put a dot right there. Now, could you imagine if I told you graph this using an input-output table? You'd have to plug in numbers. You'd have to do math. You got to do the correct math to get the outputs. Then you graph the coordinates. But because we know that this a value is what? What's the a value here? It's 1. We know that it's going to be the same exact width as this guy. It's not going to be wider. It's not going to be narrower. It's going to be exactly the same, which means I could use this pattern. Yeah, these are coordinates from the original, but I'm going to use that pattern from here, 112439. Now, what do I mean by using the pattern? You go to your vertex, and the 1, 1 is saying go 1 over and 1 up. Ladies and gentlemen, put a dot right there. 1 over and 1 up from the vertex. And then go back to the vertex and use the next part of your pattern. 2 over and 4 up. Check it out. 1, 2, 1, 2, 3, 4. And put a dot right there, please. And then go back to your vertex and go, the last part of your pattern is what? 3, 9, right? 1, 1, 2, 4, 3, 9. 1, 1, 2, 4. Let's go 3 over, 1, 2, 3, 9 up. 1, 2, 3, 4, 5, 6, 7, 8, 9. Luckily, I'm right there, right on the edge. Now, I could use the pattern in the other direction, or I could recognize something that's always true about parabolas. They have an invisible line right through the vertex. And that invisible line is technically called the Axis of Symmetry, and it provides a reflection from one side to the other. So you could actually draw a dotted line right through the vertex, and that'll provide a reflection from one side to the other. That way you could just look at one coordinate and say, that's 1 unit away from my axis of symmetry. I want to go 1 unit this way and map my point right there, reflect it over to the other side. And I want to do these reflection points in blue. This other one is how many units away? 2, so I want to go 2 this way, and I put my dot right there. And then I go back up here, and how many units? 3, so I go 3 this way and put a dot right there. Ladies and gentlemen, I have graphed this parabola without doing any math. I didn't do any math. I didn't use a calculator. All I did was recognize my H and my K. I plotted that point, and then I did this dotted line just to help me reflect my coordinates after using the pattern of 1, 1, 2, 4, 3, 9. That pattern gave me the coordinates, and then I reflected them over this line that we call the axis of symmetry. And we're done. What do you think? There's no math involved. I mean, we didn't have to do any math. This is all math, of course, but we didn't have to actually do any mathematics. Yeah. Now, if we look up here, we have some vocab. Let's review that vocab. The parent graph is y equals x squared. We already knew that. All of the parabolas come from that same type of graph, but there's some type of transformation, some type of change or modification of the original parent graph. What do I mean by transformation? It could be, instead of opening up, it could be opening down. Or maybe instead of it being with the pattern 1, 1, 2, 4, 3, 9, maybe it's wider. Maybe it's narrower. Maybe it's moved to the left or to the right, up or down. And all that comes from understanding the values of A, H, and K. We also need to know that the vertex is the most important point. It's the highest or lowest point of a parabola. It's also known as the max or min. And we also know that the vertex, that most important point, comes from HK, and you think opposite on H of whatever you see. Now the axis of symmetry, we just explained that right here. It's that green dotted line. And what is it? It's the vertical line passing through the vertex. Okay? And it provides a reflection when you're graphing. That way it makes it really easy to graph. So the axis of symmetry, let's actually jot this down. In addition to the definition, let's do this. Let's put the equation is x equals h. Now, what is h? It's right here. It's the x value of your vertex. So if for some reason I told you, what is the equation of this line right here, you're going to say x equals 0. Okie doke? So we went over the vocab. We even explained how to write the equation of the axis symmetry. One final thing on number 1. What would the domain be? Remember, domain are your x values. Does this parabola go to the left forever? Yeah. Does it go to the right forever? Yeah, I mean, it exists way up there, way off the graph, but it'll exist, right, to the left and to the right forever. So the domain, we have to put x equals all real numbers. If you just put all real numbers, I could only give you half credit. How about the range? The range are your y values. It either goes up or below a certain point. Or maybe if it goes in both directions, it's all real numbers. But in parabolas, there's a minimum point which it exists at, and it's all clearly above that minimum value. So what's the range right here? Y greater than or equal to the y value of your vertex, which happens to be -4. Excellent. Okay, there's a couple of other things I could ask you, maybe on the homework. Not right here, but on the homework I could say, well, what are the X-intercepts? What the heck are X-intercepts? It's where it crosses the x-axis. Where does this parabola cross the x-axis? -2 and also 2. How about the y-intercept? Where does it cross the y-axis? At -4. right? It crosses the y right here at -4, crosses the x right here and here at -2 and +2. And that's pretty much all we could state about parabolas. And we did all this without calculating any math. So if I asked you to describe a transformation from the original parent graph that had the vertex at 0, 0 to this new graph that obviously has a vertex down here, what kind of change did it go through? Like, obviously it did not get wider, it didn't get narrower, it's the same exact one because the a value is both 1 on both of them. But what happened to it? It got shifted where? Shifted down how many units? 4 units, that's right. And ultimately I want you to understand that the k value is what will tell you how much it shifts from the original parent graph to your new modified graph, transformed graph. Okay, let's take a look at number 2. Could somebody tell me the vertex? By the way, you're always going to find the vertex. That's your first step of graphing any parabola. What's a vertex? Think opposite on h, take k for what it is. +2, 0. I hope everybody understands that. Let's graph 2, 0. Here it is. Second step of graphing any parabola is the axis of symmetry. Okay? And that's the vertical line going right through the vertex. If I wanted to write an equation of that axis of symmetry, it's simply going to be x equals a number because that's how you get vertical lines. And what number is it going to be? It's going to be the x value of your vertex, which is really the h value, which is really what? 2. So the axis of symmetry equation is x equals 2. That makes total sense because if you go to the x-axis, you draw a vertical line right through 2, that's the equation x equals 2. And now that we know the reflection line, now we could go with the pattern from the vertex. All right? So let's go to the vertex, and my a value is what? 1. So I can use the pattern that we memorized, the 1, 1, the 2, 4, the 3, 9. Okay? So let's go 1 over, and do I go 1 up or 1 down? 1 up. Now why is that? Because the a value is positive. That means it's going to be going up, right? 1 over, 1 up. So everybody put a dot right there. Go back to the vertex and go 2 over and 4 up. 1, 2, 3, 4. Put a dot right there. And if you go back to the vertex and go 3 over, 1, 2, 3, and 9 up, you're going to be way off the graph. So you don't have to show that one. Okay? But we do need to reflect it over the axis of symmetry, and it's really easy. You get a dot right here and a dot right there. As you can see, the reflection just comes from counting. Oh, it's 1 unit away, 1 unit away. This is 2 units away, 2 units away. And guess what? We're done. We've graphed this parabola without doing any mathematics. We just understand what the a value is, telling us that it opens up. We know if the a value is 1, we could use a pattern 1, 1, 2, 4, 3, 9. We also know that h and k tells us our new vertex. How about the domain? What's the domain on this guy? X equals all real numbers. If you haven't figured it out, any parabola is going to have the domain of x equals all real numbers. It doesn't matter if it's wide, if it's narrow, if it's opening up or opening down. It doesn't matter where your vertex is. Any parabola is going to have the domain x equals all real numbers. Remember that. What about the range? Y is what? Greater than or equal to? What's your lowest y value? Here's 1, here's 3, here's 2, here's 0. This is your lowest y value, and it is at 0, solid dot at 0, and it's opening up. So y is greater than or equal to 0. You got me? Okay. I'm not going to explain all these. Which one should I do, number 3 or number 4? Number 4? Okay. So how about this? What is this new a value both on 3 and 4? What's the new a value? Negative. So what's that going to tell you compared to the original parent graph? What's going to happen? It's going to open down. Perfect. All right. It's going to open down. So let's go for number 4. You always start by stating the vertex. What's the vertex? Yeah, the highest or lowest point. But what's the actual location? You got to find it by looking at h and k. What's the h value? Okay, now remember, the h, ladies and gentlemen, yes, the h value is always being subtracted from x, and it's always inside parentheses or maybe absolute values, but it's always inside something that groups it with the x. So the h value is always opposite of what you see, and it's always inside parentheses with x. So obviously this guy does not have parentheses, right? I mean, you could imagine, don't do this, but look, I want to imagine that there's parentheses right there around the x, and if I asked you, what's being subtracted in there from the x? Nothing. So what number represents nothing? 0. So there's 0, and what's a k value? 5. Perfect. 0, 5 is a vertex. Let's go to 0 on the x, 5 on the y. You end up right here, right on the edge. What's the next thing to do when graphing? See, I didn't even give you these steps, but these are the steps you need to recognize by watching this over and over and over again. The second step is to do the axis of symmetry. Axis of symmetry is the line, the vertical line going right through it. And yes, I might ask you for the axis of symmetry equation, and that would simply be x equals the x value of your vertex, which happens to be 0. And now that we know that reflection line going right through the vertex, now we could use the pattern 1, 1, 2, 4, 3, 9. 1, 1, 2, 4, 3, 9. But obviously right here, we're not going to be going 1 over 1 up. And it's not because it's way up here at the top part. It's because the a value is negative, which means that it's going to open where? Down. So I'm going to go 1 over 1 down and put a dot right there. And then I want to go back to the vertex and go 2 over and 4 down. 1, 2, 3, 4. Let's put a dot right here. And then I want to go back to the vertex and go 3 over. 1, 2, 3, 9 down. So I have 5, 6, 7, 8, 9 right here. And from there, you just reflect it to the other side of the axis of symmetry. So this top one, it's 1 unit away. Let's go 1 unit this way and put a dot right there. The next one would be right here. The last one would be down here. It's as easy as this. 1 unit, count 1. Right here, 2 units, count 2. Right here, 3 units, count 3. We are done. We have our parabola, our perfect parabola going through all those values. What's the domain of that guy? Yes. What's the range? Y is less than or equal to 5. Perfect. The highest part of this parabola is at the y value of 5. It's all at 5 or below. So that's why we say y is less than or equal to 5. Let's take a look at which one, 5 or 6? 6. Let's do 6. All right. So again, what's the first thing when you graph any parabola? Vertex. Everybody put V, put the little coordinate thing right there. And what is the vertex? Negative 2 and 4. Perfect. Perfect. All right, so let's graph negative 2 and 4. Negative 2 on the x, 4 on the y. It's right here. What's the next thing to do after I draw that dot? Axis of symmetry. A of S. I'm just going to put it like that. And in reality, it's just drawing it. But I'm just kind of going overboard here, and I'm saying, what is the equation of that vertical line that goes right through the x value of the vertex? You say x equals the x value of the vertex. What's the x value of the vertex? Negative 2. So there's your axis of symmetry equation. And now we're going to use the pattern 1, 1, 2, 4, 3, 9. Again, because the a value is negative 1. See, the a value tells you how wide it is or how narrow it is. And all of these that we've been working on have the a value of 1. Some of them positive, some of them negative. But they're all going to be exactly as wide as our parent function. That's why we're using the parent function's coordinates as a pattern of 1, 1, 2, 4, 3, 9. So down here, I want to go 1 over 1 down. So if I go 1 over 1 down, I put a dot right there. Let's go back to the vertex, go 2 over 4 down. It'll actually be right there at the origin. Go back to the vertex, go 3 over and 9 down. It'll actually be right on the edge right there. And of course, we're going to map them over to the other side. Again, just count. It's 1 unit away, 1 unit away, 2 units away, 2 units away, 3 units away, 3 units away. And we have graphed the parabola. If the dots are on the line or off of it, you could just put arrows towards it, right? I mean, do you guys appreciate the pattern and the understanding of A, H, and K? Because look at this. Imagine if I told you graph this with the input-output table. That would be not fun. Imagine plugging in 0. Okay, let's plug in 0. Oh, that's 0 plus 2. That's 2. And then 2 squared, what's that? That's 4. And then there's a negative sign in front. Oh, that's a negative 4. And then negative 4 plus 4, what do we get out for an output? 0. We get 0. So we'd barely get a first coordinate right there. And that's not even the vertex. That's just this coordinate right here, 0, 0. So it would be very painful and very long if we did not know how the A, the H, and the K affect the parabola. Okay. So what's the domain? What's the range? Perfect. What if I said, what's the X-Intercepts? Where would it cross the X-axis?
The origin and
Negative 4 and 0. Right, here's the X-axis. It would cross at negative 4 and 0 for the X-Intercepts. Negative 4 and 0. Now, if I ask for the Y-Intercepts, that would definitely just be right here at 0 on the Y. And that's about it. That's all we could state. Now, there are more right here for you guys to practice with. The answers are on the back. But this video is already long enough.